Okay, seems you're live. Hi, good afternoon, good morning, good evening, to whichever part of the world you're joining from. I'm Mudad. I'm one of the founding members of DeFi, and we are stoked to have you today with us on a Saturday. Generally, these weekends are special for us because we get to host someone who's absolutely wonderful in what they're doing in the real life. And even today, we have a fantastic guest with us today who will be helping us in learning MLOps. Now, what is MLOps? What we'll be discussing and everything. I'll be briefly introducing that. But if you can hear me while we are live, just drop a hi or something so that we know that yes, everything is working fine. People can hear us across platforms, and we are able to see your comments and everything. So just drop a hi if you can hear me. Hi, Kamya, sorry. Can see comments on LinkedIn. Hoping to see if there are people across DeFi and YouTube also joining in. Yeah, okay, good. Hi, Mohammed. Hi, the great Anjumon. Maybe if that's how we pronounce it. Okay, awesome. You can hear me loud and clear. Perfect. So we'll probably get started. So yeah, for those who are new to DeFi, I'll probably give a brief intro of what DeFi is because every time whenever we host these sessions, we realize that there's a good chunk of people who are new to our ecosystem. So I'll probably talk a bit about DeFi, who we are, what we do. So we are basically a platform that we are a community of we are a global community of AI enthusiasts. So I'll just probably share my screen to give you a brief gist of what we do. So one moment. Yeah, let me. Yeah, so I'll share my screen. Think you should be able to see it comfortably. Awesome. So yeah, we are basically a community, global community of AI enthusiasts. We are on a mission to build and teach AI for the world. The idea is that every resource that we create on DeFi is contributed by some of the best industry experts out there, and it's consumed by this community that we have. Some very wonderful community which tends to help each other in the process. That's the best part about it. And every single resource on our platform is 100% free. Now, what kind of resource am I talking about? I'm talking about boot camps, courses, live expert sessions, AI challenges, and much more. This session, and like every other session, will be free. And so is the case with our boot camp, our courses, our AI challenges. For example, we're running an AI challenge at the moment, which is being participated by some of the good data scientists out there who are interested to solve problems and learn from each other's notebooks. Okay. I'll probably give you a gist of DeFi's website also for you to have a quick look at it. Just give me a moment. So I think you can see my screen right now. So when you go to defi.tech /community, this is what you'll see. Now here you see courses. This is where every course that you can access here is basically self-paced. You can start it when and wherever you want to learn from it. Okay. You can basically use these filters which are available out here. This is the admin accounts. I'm seeing some random courses here, but yes, you can basically use these filters and start learning whichever course you want to learn. Apart from that, there is the bootcamp section. These are cohort-based courses where it will start on a fixed date, end on a fixed date, and you'll get to solve assignments, learn in the process, and everything. It's pretty much hands-on. The difference is it's highly project-based, and secondly, it's intensive within a given date. For example, if you look for this particular bootcamp, it's starting on 15th May, will run until 14th June and similar and more boot camps running. Data engineering is a fantabulous boot camp created by folks at Data Talks Club and the principal data scientist at OLX. Similarly, we have data science with Python and a deep learning boot camp by the IIT Bombay Analytics Club. IIT Bombay is one of the leading institutions in Indian region. For those who do not know about it, apart from that, we have these live sessions. We also have AI challenges here. I'll talk about live sessions because this is where we are. We are learning from Lee Harper today. So, what is this all about? So, I'll just share my screen. So, Lee Harper is basically a data science director. He's the director of data science and AI solutions at Tallan. Now, what is it basically? It's a data science company that serves some of the biggest enterprise clients. And Lee has been a seasoned data scientist. He has worked with several other companies. He loves empowering teams, has managed few of them, and has led projects from end to end, which is where he becomes one of the best persons to talk about MLOps, which is something about taking machine learning models to production and monitoring them, maintaining them at a scale. He has been an architect for data science and machine learning for a good amount of time. He has a PhD from Oxford University and has worked with a bunch of clients around AIML projects. Today he's with us. He'll be helping us learn about MLOps, the why, the what, and a bit of how. This session that he has put across in a very lucid and simple manner for you all to understand. So let me just loop him in without any more ado. So I'll just, yeah, hi. So Lee is here with us today. Hi, Lee. How are you?
I'm well, thank you very much. And it is morning here in Austin, Texas. Although, as you can tell, I'm not originally from Austin, Texas. But yeah, I'm here now and looking forward to having some fun with you all today.
Thank you for being with us, Aurelia. I think you got a phenomenal response from the community. People are excited to learn about MLOps. So I'll probably go to the backstage, let you have the stage on your own. People are dying to learn from you. So let's get started. Yeah, you can share your screen. I'll just do this. Yeah. Go
All
ahead.
right. Okay. Well, welcome everyone, and thank you for taking the time to come here today. And as kind of you see as we go through the session, I'm actually very grateful that you've all taken the time here today. This is a very new and emerging topic, MLOps. It's also a topic where we have a dire need of people to fill it. Right, there's not a whole lot of people today who are doing this practically, and so the fact we have so many people here today who actually want to engage with this and learn about this is really exciting for me. So thank you. So what are we going to cover today? Oh, and this is, whoops. Okay, so we'll start out with introduction, kind of to me, to my journey, because I think that also helps to inform how the field's evolved as well over time. A bit about why MLOps is challenging, why is it a hard topic, and then why do we need it? That's the why question. A bit on the what, like what is MLOps and what technologies can enable this area. And then I've actually changed the last part, and it's going to be really a case study of how we can actually implement an MLOps strategy. Kind of if we've got a new project that you're ready to push to production, an example of actually doing that in the wild. We don't have any code today, just because of the time we have, but I will be kind of showing some architectures and really giving some conceptual frameworks to how to think about this topic. So let's start out with introductions and an analogy. And I love analogies. I love to have ways of thinking about these topics that aren't just technological. So that's what I'll introduce you right now. So me, as Marit said, so I'm Director of Data Science and AI at Tallan. We're a consultancy. We help many clients implement these kinds of solutions. I have a doctorate degree in chemistry originally, mostly looking at statistical properties of different chemical systems. I've been doing data science now for 8.5 years in various kinds of guises. And I lead a team of data science and engineers. And my main areas of focus, and therefore, if you ask questions later on, examples that I'll probably tend to give just because of my own experience, is machine learning primarily on Microsoft Azure, the cloud platform, and Databricks. Those are not the only two by any means. There's many platforms available for this. Amazon has some, GCP, Google has some, IBM has some. Because my experience draws from those primarily, that's what I'll primarily be kind of focusing on if we have to have specific examples given. So my journey. Now, why am I going to give this journey? MLOps is a very new field. And as a result of that, it's still very emergent, which is also why it's really exciting, right? It's changing, it's evolving, and anyone who enters it right now can have a very outsized impact on how the field actually as a whole evolves. But as a result of that, my own philosophy has changed on it over the course of years. And also what you'll hear today is an opinion, okay? There is nothing set in stone about MLOps today, really. Now, there are some general things that are best practices, but honestly, not that many things. So you'll hear today's future session that even talk to somebody else, you might hear a few things that are different to what I'll tell you. And you know what? That's okay, right? In 5 years' time, probably will have, a set of best practices and a pattern. But that isn't the case today. So again, that's part of why it's exciting as well to me. So my journey and kind of how has my own MLOps understanding evolved? So I learned to code in 2008 when I started my PhD, kind of right over here on the left-hand side. And over the course of, kind of 5 years of PhDing, I got to the point where I could write code for myself and I could use source control. So Git primarily as a source control thing. And hopefully most of you know what Git is in terms of, at least if nothing else, for storing your own code. GitHub, for example, being a great platform for doing this, pulling code down and being able to collaborate with people. So that's great. I can write my own code, but that's not MLOps. Okay. So in 2014, that was when I started. So I started my career in 2013 in data science. 2014, I was building my own applications that were compiled and deployed. So compiled code is kind of a bit old school right now. It's not really done anymore in the way it used to be. But I was building a model, wrapping it in some quite complex application development code, and deploying it to my customers' or partners' computers. Now, in that 2016, my understanding evolved, and I started to hear more about the cloud, and specifically something called microservice architecture, which is this idea, and we'll cover a bit more in a bit, where I can have an application of lots of little bits, and each little bit talks to the other bits, but they're all kind of independently built. So it's a really nice way of thinking about, especially with machine learning systems, how we can deploy them. So in 2018, now this is 5 years after I started doing data science, right? I actually architected my first cloud deployment. Okay, this was kind of my first MLOps light situation, but it was all manual. Okay, so every week we had a person spending a whole day doing our MLOps processes. Not ideal. So in 2019, I was like, there must be a better way of doing this. And so I learned DevOps. Okay, this is a developer operations. It's a deep area in application development, and I get an interest in how do I bring that kind of application development methodology to machine learning, to data science. And in 2019, actually, that's when the term MLOps was coined. Okay, the actual phrase is only less than 3 years old in total. So then, from 2019 onwards to to today, I've been really, a big part of my job and kind of the teams I've built has been to focus on that MLOps question. How do we, when you've got a machine learning model, how do we not only take it to production, but do it in a way that's straightforward for data science to understand and grasp, that enables us to automate the processes so we don't have people spending weeks and weeks manually pushing buttons to make these things happen. And actually in 2021, I launched my first ever MLOps solution offering. So that means that, a company like Tallan can come along and actually, come to a client's environment and actually deploy this in days to weeks rather than months to years, like was the case, 5 years ago. So that's my journey. And that's kind of really the evolution of my understanding. And because of how long I've been in the field, kind of my understanding has evolved with the field to some extent as well. So I thought that was important just to share and give you a feel for the evolution of these things. So before I go on to get technical, analogy. I love to think about how we can kind of, combine things. And one that I'm known for is pirates and navies. So what do I mean by pirates and navies here? So think about data science, and I'm sure on this call, many of you are probably data scientists. You probably come from more that side of the house. Data scientists teams are a lot like pirates. Okay, where do data science teams excel? They excel at solving those really challenging problems that exist with whatever tools are available at the time, right? Open source libraries, Jupyter notebooks, cloud computing resources, whatever's available, they'll throw it all together and create these great solutions for really hard problems. But the challenge here is that a lot of those solutions are often scrappy and they're designed for individual limited use, right? So I can pull someone's notebook down from Kaggle, for example, and hack around with it, but it's really hard to deploy that to a production environment. Notebooks inherently can be challenging to deploy to production. And enterprises, companies, larger applications are more like navies, okay? It's not about me anymore, it's about the whole. Solutions that comply with these wider policies, we need to kind of move together in formation with other people, within our own team and other teams as well, to really create useful solutions that can be used for practical things. We have things that are robust and observable, right? What happens if our model breaks? What happens if in edge cases, what happens if our model does things that are unexpected? How do we deal with that? For me personally, I don't really care. I've got my notebook. But trust me, the enterprise, they really, really, really care. And finally, this has been made available to a wide range of stakeholders, both internally and externally. It might be to people who are analysts. It might be to applications that have to run these models in real time. And these people generally don't understand anything about machine learning. They lack the skills that you all have in machine learning. So how do we kind of create structures to make all this happen? And that's MLOps. So to me, kind of the thing here is that MLOps turns the data science pirates into enterprise level organizational navies. So hopefully that's a useful way of thinking about this as we move forward to you all. All right. So now let's actually move into MLOps itself. Let's talk about some of the things that we have to do with it. And we'll start with the why question, okay? It's challenging, but why is it challenging? What does it solve? And why do we need it? Why is MLOps important? Why is it not an optional topic for enterprises? So let's start off with about a traditional application, right? Okay, traditional websites, SaaS products, all those kinds of things. In that traditional kind of view of the world, we have some code. Okay, now that code could be extraordinarily complex code, but it's code. Set of instructions for doing some kind of tasks, for building something. And that code gets turned into applications. Okay, so we have code version, application version. Okay, if we have bugs in our application, we'll rewrite our code to fix the bugs, and then we're going to rebuild our application. Okay, the code will only change if we change our code. Okay, we control that. So this isn't trivial. This actually is itself can be quite complicated, but this is a fairly simple pattern to follow with DevOps, and why DevOps is so robust and widely used in the modern world. So challenge one, what's the difference between a traditional application and what I'm going to call a data-intensive application? Machine learning models are an example of a data-intensive application. And what this means is that we've got code and our application, but we also have data involved as well. Okay, think of a machine learning model, right? I have my code. The code itself doesn't build my machine learning model. I need to have the code and the data. I combine those two things together, my training data, and I end up with a model that now exists. It's kind of like a compiled entity, pickle file, whatever kind of format you're using there. So what does this mean? I now have two things to version. I need to version my code like I did before. That hasn't changed. But I've also got data now to version as well. Now, data is a problem, though. Code is static. Unless I change it, my code won't change. Data is dynamic. Okay, data does not stay still. Okay, I have new products that get introduced into my data. So my data will now have a bit more products. Life changes. Okay, we'll talk about that in challenge 2. So the question here is, how do we two questions really? How do we ensure that our machine learning systems can cope with an environment that's always changing? Okay, that's not standing still. Okay, data is real life, and real life is messy, complex, and evolving. And then how do we version code and data and our machine learning systems? Okay, because I might have version 1, version 2 of my code, but my data might change 10 times in the meantime without a code change. How do I version and put together all those different things? That's a key question within an MLOps environment. How do I version things and track things? How do I expand my Git methodology to include data as well? Which brings us to challenge 2. Okay, ML observability. Now, this is the fancy term for monitoring our machine learning models. But it's observability, because often we think of machine learning models as a black box. Okay, the enterprise doesn't care about our models. We build them, we might understand them, but nobody else does. Yeah, that's a question to the DeFi group. Apparently my face is blocking the slide. Apologies. Here we go. Thank you very much. Okay, so we have our models, often a black box to most people. And that's not great. So in our view of the world, in our view of how machine models often look, right? We we build our model on training data, we deploy it. We'll talk about what deployed means in a bit and how we kind of think about that process. But what will happen when it's deployed is we'll have some new data coming in. Okay, new people, new products, new timestamps, whatever it is that's going to be forecasted or predicted in the future. It runs through the model, and we have a prediction. That's a robust pipeline, right? I can throw data in, hit in the model, and get a prediction. But are my predictions actually worth anything? Okay, are they valuable? Okay, this might work, data, model, prediction. But if those predictions aren't useful, if they aren't adding value to my enterprise, if they aren't correct even, they're garbage. And this is particularly relevant because the real world doesn't play nice. Okay, this picture here I love. It's There's a tsunami happened, I believe this is in Japan, and a boat on top of a building. Now, we might build a model to try and predict boats. Where are my boats going to be? And we might make the assumption, probably not unreasonably, that boats are always going to be either in port or on the water. Occasionally, the real world won't play nice, and we'll find that we have boats on top of buildings. How do our machine learning models cope with things like that happening? Outliers and edge cases, they do occur in real life, and they can actually occur pretty regularly and unlikely to be in your training data. Okay, that happens. We need to be able to see that, observe that, and deal with that. Real world data can change also very, very quickly. So when COVID-19 came around, those of you that are professionals will already know this. Those of you who are entering the field will, might have read about this. People's models became bad very quickly, right? There was a sudden, very, very quick step change in how people behaved, which means that any models that try to forecast sales or people's behavior, who would buy things, who would be in their jobs in a year's time, all went out the window because there was a huge change in the data in real life that caused that to happen. And what this means is that ML systems can do what we call failing silently. Okay, they create predictions, so they're working, right? There's no bugs being thrown. The enterprise, I'm getting numbers out of my model. Everything's good, but actually they're not, because those predictions aren't bad anymore. Our assumptions are violated that we used. The data's changed. So how do we get that early warning that our models are failing silently in this way? Okay, that's monitoring, observability, and a key question that MLOps needs to address. The next challenge is different. This is more of a people question. Okay, there are many, many cooks in our kitchen in a typical situation. Let's take an example here to motivate us, right? ML-powered product recommendations on a website. So this is our website, actually on the right-hand side. This is our Tallan website. We have our data science and AI offerings, and we actually don't have that many. We only have a few right now, as we're kind of developing more and more things. But we might choose at some point to build a machine learning model, and this happens on Amazon and other sites very regularly, where I've got a person on my site. Who do I want to display, or what products do I want to display to that person on the site? So in this situation, we have a machine learning model powering our recommendations, and we have a website where that's actually displaying itself. Here's the thing, though. These are probably two different teams maintaining it. Okay, the data science team probably isn't the same as the website team. Different skill sets, right? This is to be a bunch of data science and ML engineers. This is going to be mostly user experience people and website engineers. So how do we enable people to communicate across this divide between different parts of our organization? And it's actually even worse than you think, or can be worse than you think, because this example, we have our ML team, and MLOps requires lots of people to be involved. Okay, they're engineers. Okay, we need the data to be served to our models. Those pipelines, data engineers. Model builders, data scientists. Models get deployed to infrastructure. So we need somebody who knows that to be able to maintain the actual thing, whatever that happens to be, a server or a cloud computer that our models are deployed onto. DevOps, I've already mentioned that, for this, this is how we automate, code integration, retrainings, redeployments, an ML engineer potentially as well to kind of help move the models to production, as well as data science project managers. On the website team, you've got front-end developers, UX designers, and then also, fun and games, we have the enterprise's governance and enablement group as well. So this will be our security. Okay, how do we hook things together with all the security has to be in place? Central IT, if you've got an IT team, they might have rules you've got to follow as well as people who are doing your networking, the way that things connect together organization-wide. So there's a ton of people and different skill sets that are involved. How do I enable all these people to work together in useful and practical ways? So anything that we propose to MLOps needs to be able to help the people work together, not only through tools and technology, but also process. Okay, so this is like 12 different job descriptions. Okay, how do I move them all together in lockstep? Again, this idea of the Navy, right? All these people, all these different boats in the Navy. How do I get them moving together in one way? So, quick reminder, what does MLOps need to do? So it needs to provide early warning and proactive response to issues with our machine learning models, data changes, bugs, those sorts of things. We need to enable multiple teams to work together in a common way. And we need to be able to have a good quality versioning of ML models in a changing environment. What's old, what's new, and what I'm moving towards. This is, to me, a minimum set of requirements for a MLOps solution to be actually useful and practical for people. Challenge 4, though, before I move on to the what, is a skills gap. And this is why I'm actually very grateful that you're all here today participating in this. Most data scientists, in my experience, there are exceptions, of course, but they don't understand software engineering best practices. Okay, I could count the number of data scientists that I know that do regular unit testing on the fingers of my two hands. Most don't know how to do DevOps automation or release management as well. These are common software engineering things that data science typically, just due to the path we've taken, tend to lack. Similarly, though, most software engineers don't know data science nuance. Okay, they can probably build a model, dot predict, dot fit, all that stuff's pretty easy, but they understand proper statistics, feature engineering, metric design, other things, all those really hard things that we know form a solution, but just require years of experience and education to really get your head around how that works. So there's a gap here between these, between this, right? MLOps kind of fits between these things. The fact that we have data scientists and scientists who want to bridge this gap is really, really important. And this really is what will guarantee the field has a future long term. So thank you very much. And just to kind of really drive this home, okay, doing MLOps, not really a thing. Okay, I personally don't know a single person, and I know quite a lot of people, that can do every single role well enough to make MLOps work on their own. Okay, the idea of the MLOps engineer who can do everything, all the machine learning, all the software engineering, all the DevOps, all the security, all the networking, all the user experience design, that just doesn't exist in my experience. So you're always going to have this kind of cross-functional team that implements a full solution in this way. But the more we cross paths, the more we understand and have this common understanding together, the better off we're all going to be because we talk this common language together. And I class myself in this, so like I can do a fair amount of this stuff, but I can't do every element myself of an MLOps solution. So if this all sounds like crazy, how do I learn all this stuff? Don't worry, it's really, really, normal that you wouldn't learn everything about MLOps well enough to do it to production across the board. But we should still try. Okay, so I'll pause quickly. Do we have any questions on the why before we move on to the what? Or some of the what?
There is one question probably it's your call if you want to pick it now or later. So a community member has asked if it's advantageous to be from a software engineering background instead of a data science background if somebody wants to be into MLOps.
I think both can work because each background brings something different to the table. There is an advantage to being a software engineer, and actually today most people in MLOps, in my experience, are originally from app dev or software engineering backgrounds. Not all by any means, but a good number are, just because the skills there's almost like a lower barrier to entry there because you already know DevOps and those things. But what you often don't have is the understanding of the nuance behind machine learning systems, right? So if I as a data scientist give you a model to deploy, to turn to a production deployment, because often those people lack the deeper knowledge of the system, they inadvertently change it while they're implementing it. So having then data scientists come in as well who can kind of bridge some of that gap is also really, really, really valuable. And we are seeing more data scientists take an interest in this field as they kind of are in it for a few years and realize, oh, production, that's a thing if I want models to be useful. So I'd say probably today, it's a more common path to be a software engineer, but I do see that changing over time. And honestly, I see both kinds of people contributing something to the solution. And really a team would benefit from having both kinds of people kind of on there as well. So I see a few more questions as well. So if you want, I can crack through some of these. So certifications, honestly, like the field is so new, there aren't really certifications, at least none that are universally recognized. That will probably change in the future. But the common ones to have that can help here are, so most MLOps is done on one of the big clouds, right? You know, Azure, AWS, GCP, IBM, Oracle. I guess we'll class Oracle in there as well. And similar things, and even Databricks. These all have like cloud certs, like general cloud certs in like DevOps and software engineering and data science. That between them can kind of help to, you know, give some level of certainty that you have the skills in place to do MLOps. But I wouldn't say there's a single cert yet. And it's so, I mean, we only really saw, I think Stanford introduced a MLOps course. Oh, whoops. Apologies. Stanford introduced an MLOps course, I think, last year for the first time, like this academic year. So it's new enough that doesn't quite exist yet, but cloud certs can help give you some level of introduction to the concepts, at least, that helps you to implement such a solution. And the other one, I don't think there really exists a common understanding yet of what full stack ML engineering really is. You know, that is a good question, and I think that question will probably have an answer in 2 or 3 years' time. I don't think there's an answer to that question today. Even at different companies, the definition of an ML engineer can be quite different. At some companies, ML engineers also do some data science, for example. At other companies, they're pure engineers who, you know, sit apart from the data science team and just do the like operations parts of MLOps. So, to both those questions, the kind of theme there is that it's really too new yet to have those terms well defined, but I think they will be well defined in a couple of years' time once the field's matured a little bit more. Which is why getting into it today is great, because it means that you have a say potentially in what those answers to those questions might happen to be in a couple of years' time. Cool. So I hope those were helpful answers. If there's any more stuff, keep it going in the chat, and I'll move on, and I'll have another break in a little bit to go over some more questions. Let's talk about what is MLOps. So this paper here is the seminal initial paper in the field that kind of really started the whole thing. So this was published in 2015 by Google. Hidden technical debt in machine learning systems. If you want a starting resource to read about the field and kind of how we start to think about it, this is an amazing paper to do. It's freely available. Just literally Google this particular title. It'll come up. It's about 15 pages. It is a great read. I do strongly recommend it. I keep referring back to it again and again, especially in talks like this. It's got some great concepts in it. But this basically was the first time when people were like, well, yeah, but how do we do machine learning in production? How should it look? What should we do? And largely because data scientists, you know, weren't doing the best job in the world of making this happen, and they were creating what's called technical debt as they were doing it. So great paper, recommend that you read it. So this is just 2015. This is like 7 years ago, right? Not long ago at all, in the grand scheme of things. So how do we define MLOps? Now, again, there's not necessarily a single definition that exists. The pithy one is DevOps for machine learning, which, well, it's in the name, but it's not massively helpful in my view. The better one, this is what I actually pulled from Wikipedia. It's actually a pretty good definition. I added a few words in here of just my own flair. But MLOps is a set of practices. And to me, that includes people, processes, and tools that aims to deploy and maintain machine learning models in production, both reliably and efficiently. This is the key thing here to note, is that it's not just tools. It's people and process too. And those three things, people, process, tools, and honestly, in that order, are what really help you to define and figure out how successful you're going to be in this field. Okay, there's not a tool you can use to make this work. You need to have all those three things in place together. So this is kind of a model view of MLOps. And I'll refer back to this, and I'll kind of take through each step in this as we go. Again, this is now definitely my opinion. Okay, this is how I practice this. This is how I think about this. You will see other models as well of MLOps that are no less right. Well, there are some wrong ones, but there's no single right one at this point in time. So this is my practice. This is how I do it. But you'll see different models as well that are no less valid than my one. So to me, there's three main pillars of an environment that MLOps exists in. There's our dev environment. Okay, this is the area where you're the data scientist, you're playing around, right? You're building your models, hacking around in notebooks, however that looks. Getting to the point where you have a model that you believe is ready to go to production. You've done your testing set, your due diligence, you've validated it, all that stuff's been done. We then have a process of code integration. Okay, this is called CI. If you do it correctly, continuous integration is one of the DevOps pillars, is CI. And this takes us from our dev environment to a staging environment. Okay, this is where we kind of have our production releases. And we'll talk about what these things mean in a little bit. But basically at that point, we've tested our code. We have a model that we now is literally ready to be button pushed and pushed out to a live environment. But that involves some kind of change management process. Okay, this might involve a person having to manually approve it, saying, yes, it's ready to go. It might involve some kind of, security review if your org has that, right? This could be many different things based on your situation, but it's going to be there. We then have our production environment. So this is where we're actually doing our monitoring and our operational work, which includes both continuous deployment, which is the other pillar of DevOps. CI/CD is a thing that you'll hear very regularly in a continuous deployment, follow that application, code to application scenario. But we also have one more pillar here, and that's continuous retraining. This is the way that we deal with our models, our data changing over time. So for those of you that are software engineers that have done DevOps in the past, that are familiar with CI/CD, the conceptual change here for you is rather than being just CI/CD, we have an extra pillar. So it's now CI/CR/CD. Okay, integration, retraining, redeployment. And those things are different, right? Integration and retraining are two separate processes for good reason as well. But then, of course, once we've done our operations piece, we'll have some people who are going to be logging, analyzing that results, and those results from our live environment will inform your next model version. Okay, so then you as an example will go, you'll say, oh, we're getting these bits right and these edge cases wrong. I'll go and redo my model to account for the edge cases, and then I'll push up new code. So we go round and round this cycle, as we should, right? Data science is an evolutionary field as well. Models don't just stand still. We want to keep improving and making them better for ourselves and our organization. So CI, CR, CD. And really the CD part of life from DevOps, the question there, actually I would say that the CR-CD combination is analogous to your CD piece in software engineering. The CR piece is different, but it comes after you've completed your CI process. Okay, so let's go through a few steps now and kind of level set on what a few things mean. So I figured that some of you may not even know. I know that for me, for years, I was hearing the word, in production. And I was like, what does that mean? I didn't know what it meant for years and years, actually, of my life in this field. So what does it mean to be in production, especially in today's world, right? I mean, it could be many things. How does it look in today's kind of modern ecosystem? So let's start here on the right-hand side. Typically, when we're deploying a machine learning model, and this is quite common in modern architecture as well, so I do a microservices, we deploy our model in what's called a container. Okay, and Docker is the typical technology used for containers. So if you haven't used Docker before, check it out. It's awesome. But what this means is that I can have my model, and I build it into this kind of little system. And then I can push that little system wherever I want to push it to. Linux, Windows, Mac, the cloud, actually doesn't matter. Anywhere that Docker will run, that will run as well. What that means is that I can package my model up, and I'm guaranteed that my model will work anywhere. So that's kind of cool and kind of nice. That's good for me, my own personal use. How do I allow the wider org to use my model? This really comes to the idea of an API, an application programming interface. So an API is a gateway. It's a way into my container that allows anybody, whether they understand machine learning or not, to be able to use it. Okay, it gives me a common, straightforward interface that anybody can use. So I can use it myself. I could, have an API and I could write some code to call my API on my own system. Or what I could do is have an application, which could be software, a Jupyter notebook, or really anything else. It doesn't matter, just something that's a software application. And what it will do is it will send data, in this case via a JSON request. That's the common kind of format for these things, to my API. My API knows how to run my model, so it'll go and do my model. And what I'll get back are my inferences, right? My scores, my forecasts, whatever my model is doing, again, as a JSON response, which this can then interpret. So this is kind of a typical kind of very high level view of what production means today, right? Containers, an API into my container, and then something that can call that over the internet communication wise. So from okay, I actually had an example here of doing that in code, which seems to have gone. So let me quickly, I'm actually going to go quickly and show you a code example, because that's helpful here. Okay, so this here is just me, my coding IDE, and let's see if I can zoom in a bit. I can't. This is an example of doing this, right? So in this case, I actually have a little API built. All I do is I import two libraries, request and JSON. No machine learning in sight whatsoever. I have a URL, which is my API. I have a key because it's secured, so I have some security on it. And then I'm going to pass, in this case, a single column of data, right? Just a visit ID, this is for my case study later on, which I'll talk about in a bit. We then turn this kind of basically Python dictionary into a JSON via this JSON.dumps command here. We create some headers, which is a JSON, I think it's required for JSON to work, including our authorization, our security. And then all we have to do is request.post to that API with the data that we had. And this RESP here, when this comes back, this will just be the little JSON with our scores of our model in it. So this is what I mean by saying that now in production, we can have everyone talking together, is that people can write bits of code like this that are pretty simple, and really for a software engineer, this is like a bread and butter thing to do. So they can now easily integrate with what you have. So very, very powerful thing to be doing. Okay, go back to my slideshow. Okay, so step 2, how do we move ourselves to production? Okay, it's one thing to just say, I'm in production now. How do I do that? Several answers. One is Git. Okay, this is for our code. Many of you will have used Git before. For us, when we're doing this stuff, we want to be careful with how we do things. So what we typically have is kind of there's many ways of doing this. I often use this kind of 3-branch system. There's many, many more available. Software engineers, I apologize if you have better or more complex pathways for your work. But for us, we have a master branch. This is our gold standard branch. The code in here is our pristine, best ever code, beautiful, tested, definitely works. This has to be at all costs protected. So we have a dev environment as well. Okay, this is a parallel branch this code is like silver standard. It's good, but it may have a few problems in it. So what we do as a software engineer, or as an ML engineer, or as a data scientist, is what we do is when we're building a new feature, right, a new feature engineering bit, a new algorithm, how that looks. We pull a branch off of development, do our coding, and then we remerge it with development. Okay, and we keep doing this till we have enough stuff that we want to then say, okay, we now have our next production machine learning model. Great. We then merge this dev environment with master, test it. And then we create a release. So we do automated tests. We automatically build our model, our code, and we create a release. These releases are how we'll version our code. Okay, so we'll have release 1, release 1.1, release 1.2, and so on and so forth. This is the idea of CI. And what this means is that if in the future something goes wrong and we want to revert back to our last release, we can do that because all of our releases are stored here permanently in our source control as their own sort of standalone code entities. So this is how we can kind of have this workflow. And again, this itself could be a whole topic, just how this works. But at high level, this is kind of how we do kind of Git in sort of a production environment and how we move towards that situation there. And this is just some technology that can be used to enable the kind of CI process. There's many more as well. These are just a small set for you to kind of start with having a look at if you want to. That's the code. Now, remember, of course, though, machine learning models have code and data. So in this case, we have other tools for tracking model building. So MLflow is a great open source one. I just cribbed this one from the Databricks website. MLflow is a way of basically enabling source control for our models. So what we saw before was source control for our code. With MLflow, what we can do is we can track parameters, metrics, right? Precision recall, artifacts like our PR curve or our ROC curve, right? We can plot these out and store them as part of our actual model version. Metadata and the models themselves. So with these model version tools like MLflow, this means then that we can have what's called a model registry. And a model registry, you can think of it like this is that GitHub for models. Okay, there are other ones as well. Hugging Face has one for NLP models. They have a model registry for NLP models. But you need something, MLflow or Hugging Face or something else, that can act as that repository for your models in the same way that you have repositories for your code. And for the same reasons, right? So now if I have to go back in a year's time and say, hey, what was my precision for the model I trained a year ago? It's here, right? It's in our registry. We can go and look at that. If we have a model that we deploy and something goes wrong with it for some reason, and we're like, but our model 6 months ago was working fine, we can then go back to the model 6 months ago via this model registry as well and ensure that we have things that we can always go back to. So MLflow is great. I recommend looking into it as a kind of starting point for tracking and versioning models if you aren't using it already. It's kind of nice and kind of does this model source control for you. So now we've got models in production. We've moved into production via our registries. They're in our containers. How do we keep them there? And this is just a step 3 then, which is this bit. If I just leave a model in production for a long, long time, typically we see a degradation of quality over time. And there's 2 reasons, and this is called data drift or drift. And there's 2 key kinds of drift that can occur that can destroy our model quality over time. So one is concept drift. This is when the relationships between input and outputs change. Now remember that really in modern machine learning, what we're really doing is learning some pattern matching between inputs and outputs. If that pattern changes, we cannot expect our models to keep performing well. Again, COVID-19, great example here, right? Suddenly people's behavior massively changed. The relationship between inputs and outputs overnight shifted dramatically. This is concept drift. And the other part is data drift, where the actual distribution of the input changes. So with concept drift, the input might look the same, but the outcomes were different. People were not going to the shops anymore. They were online shopping instead, for example. With data drift, our actual input data changes over time. So this could be seasonality. is a great example of data drift, right? Ice cream sales in the summer, at least in, say, Europe, where it's warm in the summer and cold in the winter, are very different between summer and winter. The data drifts seasonally, and so we have to account for that either by deploying a new model for summer or winter or doing something else. So this is the kind of idea of drift, and this is why I have to monitor our models to make sure that we're still getting good quality predictions and that our input data isn't changing too much to make our models invalid. This is a very, very hot area for ML startups right now, and here are a few examples. There is not a single good way of doing it or a best way of doing this yet. Different people do it in different ways, and that's fine. Hence why it's really a startups thing. There are some emerging open source libraries as well that are just starting to come out, but they're all still pretty early on. So this is an area that's going to change dramatically over the course of the next few years. And I'll be very curious to see which companies end up winning in this monitoring space for drift detection. So we really have three kinds of monitoring to look for this. Okay, so one is to monitor key input features. Okay, the input data we have. Now, this is harder to do at scale, just because, if I have billions of rows of data, that's a non-trivial problem, as I'm sure all the data engineers here could attest to. It also doesn't capture interaction effects. So often in machine learning, one feature alone might not do the trick. It's the interaction between two or three of them that really matter. This only captures the features one at a time. So it's hard to capture those interactions. And if I monitor too many features, if I've got 500 features and one of them drifts, does that really matter? It might. If it's the key feature, it might matter. But if it's a very minority, say 0.05% feature, it probably doesn't matter. So you'll be very careful about being too sensitive to a single feature if you've got tons of them in place. Number two is then monitoring your model outputs. Okay, is that changing over time? Right? Am I seeing different shifts in my distributions of my scores or my forecasts? Now, doing that's very easy, right? It's very easy to monitor my output models. It's just coming because that's what I'm getting out of my models every single time. But in my experience, that can be sensitive to outliers. A few outliers commit those distributions look very different, even though they're maybe not so different. So again, you've got to do good quality statistics to account for that and make sure that you aren't kind of having problems with outliers biasing things. And then three, monitoring the ground truth of your predictions. So this is the gold standard, right? At the end of the day, nothing else really matters. All that really matters is that your model is giving good results that are correct and accurate. Now, this can be easy. Sometimes on, say, website clickstream traffic, you get instant feedback, right? Did they buy a product or not? Okay, you might know that within 5 minutes of the model making a prediction. So monitoring that's actually not very difficult. But it can also be very, very delayed. Let's say you're doing work on marketing campaigns to optimize them. In email marketing, typically it takes 2 weeks, rule of thumb, for the full campaign's effect to be felt. So you might have a 2-week or even longer, sometimes, delay between the prediction and its ground truth being available to you. So great to do, and you should do it. But again, it's not always early warning. It can sometimes be a lag from the other two, which give you the early warning. So all three are great, and you've got to really just pick the combination of those three monitorings that work for you and your situation, given the constraints I've just outlined here. And so what you're looking for is something like this, right? Where rather than have this model kind of drop off at various points and it's starting to fall off, you retrain in this continuous retraining pattern, redeploy it. So this is the CR/CD part. And then you should get improvements in your prediction occurring. So you kind of end up with the kind of conceptually kind of this humpy picture here, where yes, you might see a bit of degradation over time, but it should be much less than you see if you're keeping it static. Bear in mind, the code may not have changed at all here. Same code, but these retrainings occur because the data is changing. But I'm now going to contradict myself. In practice, most people don't actually do this. So you think I retrain once my model quality is going down. in my experience, people often don't do that. Now, they do in some cases. If you have an expensive retraining, let's say you've got a neural net that takes a week or more to train and it costs you thousands of dollars per time on GPU machines, yeah, you want to use monitoring to tell when to retrain. In practice, most people's models don't do that. They take a few hours to train at most. They're fairly cheap to train. So most people, in my experience, train on 3 different cadences. Obviously, updated code, you need to retrain, right? Of course. Most people do it on a schedule. They say, okay, I'll train every week on a Monday night, or once a month, or once a quarter, whatever makes sense for your use case, and they keep their quality up that way. Now they probably train more often than they need to in that case, but it's so cheap it doesn't actually matter. Okay, and then also if you know you've got a data change coming, like you've got a new product in your product suite that requires a retraining, you might manually kick off a retrain to account for that kind of process as well. So although monitoring and monitoring-based triggering is ideal for retraining, in practice, this is simpler and actually tends to work fairly well. But it doesn't replace monitoring, but it replaces retraining based on a monitor trigger. So just be aware of that. Theory and practice can be different. Last thing kind of then on this kind of area is, and I know we're kind of actually coming up on time, is continuous deployment. So doing this, what I call the safe way. Now you'd think if I'm retraining, I'm just going to overwrite my deployment. Don't recommend that. What tends actually to work better here is to do what software engineers will call a blue-green deployment. Sometimes called a champion-challenger deployment. And in this case, if I've got my new model version, rather than just replacing my existing one, what I do is I create a blue model, which is my initial one, and my green model, which is my new one. And what I do here is I put most traffic still towards my current model and a little bit towards my new model to make sure its performance is what I expect it to be. Because sometimes models in production live don't behave as you expect. This helps us to diagnose that early on in the process. And then what we do as we kind of move through deployments is a sort of controlled rollout. So our blue, we start at say 100, go to 80-20. After say a few days, might do 50-50. We might then go 20-80 or just straight to 100% of the green. So we kind of have this almost like, kind of gradual changeover of my deployments. So I can monitor that and check that nothing is going wrong in my new deployments as I go. And again, quite common in app dev as well. So we just borrow that very successful principle from them for us as well. So hopefully that's been helpful to kind of see how these different things work, how I can go from dev to production via the staging environment with a bit of CI, continuous integration, bit of change management, redeploying and retraining with controlled rollout, with model versioning, with monitoring and maintaining. And then I'm sure that most of you can just figure out that we can then use those monitoring results to then redo our model if we need to in response to the feedback that we get from the live environment. Parting thought on this one is that here's challenge 5. This is the ecosystem of machine learning today. And this isn't even the full one. This is just some of it. And you can see here under CD and under tracking and under model management, there's tons of different options out there right now. This is also a challenge. There is no single right platform or right way of doing this. There's tons. And so a challenge that I don't have an answer to yet is that as you start this field, you've got to start sifting through all these different technologies that exist, both open source and proprietary. And that's hard. But I just thought I'd raise that here. This is also part of why there's no right answer to this yet. But I'm sure that over the course of the next, if you again 2 to 3 years, the list here will get pared down a little bit, and we'll start to better converge around a couple of key winners in the space. All right, so I know we're now at 10:30. Now I can carry on. Mudit, do you have any more questions you want to go after?
Yeah, there are a few questions, but I think we can take it towards the end. Depends on your bandwidth. Uh, if you want,
I have time. If people have time,
awesome.
I have
So yeah,
plenty
we
of
can
time.
probably take them up towards the end. That'll be best for everyone. But I see
Okay.
people are putting them up, so that's good because we are picking them up. So yeah,
Yeah.
they can start putting it on the comment section if they have any queries.
Cool. Okay. All right. So, but before, are there any questions in understanding before I move on? Or is all that, do that make sense to people? Was that kind of was it relatively clear? All right. So then the last part then is a bit of a case study that I'll go after. So we've gone through some concepts right now, kind of some ways to think about it. A lot of these themselves are deep dives, right? I could talk for an hour on most of those topics that we just discussed in like 5 minutes each. So let's talk about a real scenario that I covered for a client some time ago. This is fully anonymized. I'm not going to tell you what client it is or any deeper details. Please do not ask. I can't tell you. But this is a good thing just to talk about a real example of how we went about architecting out and thinking about the deployment based on the real situation it was being deployed in. So a data science team built a machine learning model. Okay, and this model used clickstream data for its training. So clickstream data is on a website. You click between different pages. What were the pages and where did you click and when? Okay, that's the data that they were using for this model. And they wanted to predict the probability that a person needed help on the website. Okay. And the aim was to have an intervention, in this case, a little chatbot appear, when a person needed help. They wanted to be unobtrusive and only show it when the person needed help, with what they were looking for. The model was ready to go. They wanted to deploy the model to production and then implement an initial MLOps strategy. Okay, and I mean initial, right? What I showed you before was the full thing. We'll talk here as well about what their starting point was with MLOps. So that's the situation. Clickstream data, does a person need help or not based on their journey in the website? So the first thing that we have to do here is to ask questions. And we ask questions here that are different to certainly what a data scientist would ask for their model building, and even different to what some software engineers would ask. So here are some key questions that we asked that would affect how we did our production deployment for this group. First up, is your model a real-time or batch model? Right? Do you need to be sending the model real-time inferences? Or could I, once an hour, once a day, do a big batch prediction? And Mudit, my picture's blocking some of the slide. Could you move me to the left-hand side? Thank you. So in this case, they needed real time. They needed to be able to send an inference to the model and have it return a result. In this case, in under a second. Because the next response is, what latency do you have to have? How long can your prediction take? How long is that allowed to be? For them, it has to be really, really fast. Again, that will impact how we deploy this. What would the user experience be? You'd be surprised how few data scientists think about their end user when they're building their models. In this case here, the intervention would occur at least 5 seconds after a user loads a new page. And again, this is good for us to know to help design out how things are going to look. They didn't want to just have a new page in the bot appear. They want to give people a bit of time to read it, look what was going on before flashing it up. Another question that people often don't think about, are the other team, bear in mind MLOps, the Navy, we have multiple teams. Do they know you're building a model for the website? The website has to call your production model. Do they know that yet? Are they aware? You'd be surprised how often the team doesn't know that because the data scientist didn't show them, hey, the model's ready to go. You need to call our model from your website. And I've got a question here about latency. Latency is if I've got my model and I basically do dot predict, if you will, or I send a request to my model API, but basically do dot predict. How long will my model take to do dot predict and return an answer? That's the latency. So in the case here, if the model received a piece of data to make a prediction on, that prediction had to occur in under a second. And for us in engineering, that's more than just .predict. That's the request being sent across the internet, arriving, getting the data, doing the prediction, and returning the result. So there's actually quite a few things to orchestrate there in that total latency journey. But that's latency, how long it takes to basically get the prediction back once you request it to occur. So next up, metrics to monitor. Remember, we have to monitor our models. How do you want to do that? And this group actually didn't know at the present time. It wasn't obvious to them or to us what metrics were most impactful to monitor the success or failure of this model. So what they wanted to do, and this is actually very often the first step in MLOps, is to record the predictions, monitor them, yes, but then analyze them manually. So rather than monitoring a metric, they would analyze it manually, and in the future, create the metric to do the automated monitoring on. But to make up for that, back to what I said earlier, they were going to retrain once a week on a scheduled trigger to make up for that. To keep the models fresh, to keep them updated, they would retrain once a week on a regular cadence. And the final thing is, how much traffic do you expect to get? Again, a big question for how we deploy it, which we'll come to in a minute. And the answer here was about 200 requests a second. Okay, so that's every second we have to expect and provide 200 inferences that could come at any point during the second. So all of these questions are important to help us figure out how we're going to architect out the solution for them in production. So how do we do this, right? So I'm going to build this up for you a step at a time to understand how a real production deployment, a modern one in the cloud, is going to look. So how did it look like? So the starting point, they have the website. Okay, a person's on the website and they've got a visit ID. Okay, they've logged on, they've been there for 10 minutes. That visit ID is being tracked. If they shut it down and open up a new window, they'll get a new visit ID. The website will send a visit ID to our API. And our API here, because of what had to happen, is actually what's called a serverless application. Okay, this is like an Azure function or an AWS Lambda is a common example of this. And there's other ones as well. And basically what this means is it's just sitting there waiting to get a response, a request, and it's not doing anything unless it gets a request. Okay, so this is kind of how we built our little API gateway to everything else. Now, and again, if we look up serverless, that's that again could be a whole deal in its own right. But go look it up. Azure Functions or AWS Lambda, definitely worth reading about because they're a very common thing to use in these kind of more complex deployments. So that's a visit ID, but that's not the model. Of course, use clickstream data. So how do we get that? So once the API receives the visit ID, this function now does a whole bunch of stuff. The first thing it does is it calls out what's called a feature store. Now, feature stores are a modern thing in MLOps, and this basically is saying that I've got a database or a data lake or something where I've got my features for my machine learning model, right? The actual inputs that go into my machine learning model, the features, pre-computed. With sub-second latency, we don't have the time to do feature engineering or data wrangling in the inference. That would have taken a couple of seconds. That was too long. So we had to have a way of pre-computing our features the model would need. So we had a feature store. The clickstream data was separately kind of brought in by data engineers to this feature store. The features were computed in this feature store, and what that meant was then all this had to do, rather than complex averages and sums and counts and other things, all it had to do was a simple query, right? Select star from the feature store where the visit ID is whatever number, 1, 2, 3. So this becomes a simple lookup. Feature stores obviously they're controversial right now in the field, but some companies who make feature stores are like, you should always have a feature store. My personal experience is that it can make great sense in some scenarios. In this case, the feature store made a lot of sense. We actually needed it for this solution to work. In other areas, though, I think feature stores are overkill. That's probably, again, that's an opinion, and that's probably a controversial thing to say nowadays. But this is kind of my thing about feature stores. But again, look them up. A number exist, and they're good to understand and know about, even for your own data science work. But in production here, it means that we can just easily query the feature store. They're all pre-computed. We pull the features into our model that way, rather than having to compute them at inference time. So we have this data now. This data from the feature store exists in our service application. So now what we do is we have we deploy our models to containers, and we'll have the application here calling our container, like I showed you before with that bit of code. But there's a but here. This is one container. If I'm expecting it 200 requests per second, and it takes half a second to run a prediction, this can do 2 per second. That's not going to cut it. So we have to scale up our deployment. How do we do this? You might have heard of this already as a technology. What we can do is use something like Kubernetes, which honestly is the standard now, to build a bigger and more robust deployment. Again, Kubernetes is super complex. I'm not going to pretend to be an expert in it. I am not an expert in it. But from our perspective, what we're doing here is we're then going to have this cluster, Kubernetes cluster, of many containers. This will replicate our containers. So rather than having one, I can now have 100 containers at the same time, all ready to receive an inference, and all ready to give an inference back to the application here. And Kubernetes is nice because it has what's called a load balancer, and it will automatically route inferences to whatever container is available to receive them. So I haven't got to worry about all that. It will do it on my behalf. Kubernetes is kind of complicated, but for this sort of stuff, it's really valuable to give me this big scale that I can work at. And again, most app dev people here are probably aware of Kubernetes and have used it in the past. Very, very useful technology for our production-grade deployments, especially at scale. And 200 requests per second is quite large scale. So an inference comes in, it gets routed to an appropriate container within my cluster, does .predict on my model. Back comes an inference, a score in this case. And then my service application will now return to the website the results of the model. So in this case, what do we return? We don't just return the score. It's always good practice to return more than just the score. So in this case, we return the visit ID. Again, that's our kind of primary key. We return it back, so it's always clear what we predicted on. We return the score, the model version. Again, for down the road for our monitoring, really important to know which model generated that prediction at that time. Code version as well, again for tracking, and then date time. So all of these things mean that we're now, although monitoring isn't automated yet, we're setting ourselves up for the future with all the things that we're going to need once automated monitoring becomes a thing that we need. And our audit trails built as well, we'll always be able to refer back to the prediction and the model that made it. So this is kind of how we went about constructing this deployment. Of course, MLOps was involved here as well from all the versioning that was done separately. But this bit kind of covers the monitoring, because again, there's now a database on the website side where all our telemetry is being stored, and it covers kind of how we go about routing requests and actually making them do stuff that's useful. So again, kind of back to the code. This is kind of a code snippet here. In this case, who's using the API? It's the serverless and the website. which again, by a few lines of code, we can have the website and the serverless communicate. So our website team is fully empowered to use this without much integration or knowledge of it required at all. It can just be a black box that the data scientists provide to use. Okay, so before summary, I do have a nice question here about who owns the feature store and how does it refresh features. So in the case here, the feature store was owned by the data science team, or actually by the data engineers on the data science team in question. And in terms of refreshing, so there was the website telemetry would come through every few seconds. And it was processed again. The data engineers had built a pipeline from the website to the data science team's work area that would pull that telemetry in when it became available. So every few seconds, it was updated. Very performant, very fast engineering pipelines. And so what they did is they added one more step to that pipeline, that rather than just bringing the data into the training set that was part of the data science workload, they would bring that data as well now into the feature store as kind of an additional place where that landed. And of course, they had to build out the features into that pipeline. So it was a bit more complex than the initial workflow. That's how they did it. So the data science team are the ones that the bigger part of the data science team are the ones that owned and maintained the store, and that got refreshed as part of the every few seconds telemetry receiving. But you can refresh it on a number of different ways, based on really whatever engineering criteria you had as a data engineer, because really it's just a database, a fancy one, one that has a name, but it's just a database really that's being populated over time. And in the case there, to make it fast, we actually only kept a day of telemetry. So at the end of each day, or after 24 hours, data would drop off and be replaced. So that lookup was ultra fast. Okay, so to summarize, this is my nice pattern here that I like to think about, right? From dev, staging, production, where we have CI, CR, and CD. Again, other models exist. This is the one that I have in my mind that I think that works for me in my practice. What we covered? We've covered some challenges to say with deploying and maintaining machine learning models. So tracking and versioning, observability and monitoring, getting teams together as a unit, skills gaps, and the fragmented technology landscape. We've also thought about what we need in an MLOps system. Okay, what does live mean today, typically in a data science environment, in a modern data science environment? How we implement a release workflow for code, and how we think about tracking and versioning models, code, and data. And then how we monitor deployed models to retrain and redeploy them over time. And then finally, I covered a case study of how we think about deploying to production a real-life, at scale, machine learning system, and some of the concepts and technologies around that. So thank you very much for your attention. Do appreciate your being here and being an active audience. And with that, I will open up to some Q&A. I have plenty of time, so I'm in no rush. So Madeep, you can be here for whatever people need.
Yeah, first off, that's a really brilliant presentation. One of the best ones that I've seen in all the live sessions that you've hosted today. So thanks a lot for putting that together for our community. I think there are several questions that you have been answering around feature stores and how somebody can learn it. There are a few generic questions that were shared earlier, and then a few implementation related questions. So we'll pick all of them one by one. So we'll probably pick this one. So this is a question related to gaining experience in the field. How and where can someone gain experience in MLOps outside of a company, or are there any entry level opportunities in this field?
So MLOps is kind of one of those interesting kind of fields, right? It is new, and what it means isn't particularly well established. So in terms of gaining experience, typically speaking, you'll probably want to choose like a path into MLOps, right? So if you're already a data scientist, for example, well, great, you've probably already got models that you can push to production. And just pick a model. Doesn't need anything fancy. I built a demo once. I took just a data set from Kaggle, pulled it down, built a very 5 lines of code model, and then used that for my demos of MLOps, right? But in terms of then, kind of, you could also then go the DevOps route, okay, and kind of become a DevOps engineer and kind of come in that way. But the kind of typically the ML engineer title is the one that tends to incorporate most MLOps. And yes, because it's expanding and there's a massive talent shortage in the field, the ML engineer role is becoming available to people who are more entry level. In fact, I've just hired someone entry level for myself for an ML engineer. I am now good enough to be able to train somebody in that field to do that. So I think that's the key question there in terms of entry level in the field professionally. Companies that already have MLOps going, companies that already have a person, perhaps like me, who's an MLOps architect and can already have that process in mind, they're equipped to hire people who are entry level because they can train them up. Companies that don't have any MLOps, and honestly, right now, that's the majority of companies don't have MLOps, in my experience. Even companies that you think would have, like Fortune 50 companies, don't. Often. Some do, many do not. They probably won't take entry level because they need someone to come in who can actually architect the solution for them to start things off with. So go on there, look for people who are in the field, either thought leaders or who are active on, towards data science or other blogs. Where do they work? If they work there, there's probably MLOps there, and they're likely to have at some point more junior ML engineering positions available, to look at. But today, what could you do today? Find a model, any model, doesn't matter, okay? And then go on, use MLflow to track the model. Use MLflow to version the model because it is all open source, right? No money required, okay? And it even has some simple containerization things. Okay, use MLflow to package your model and deploy it locally to your computer as a container, and then call it via that request and JSON library. All that is on MLflow. They have tutorials on it as well that you can use to start figuring some of that stuff out. And then the next step after that is a bit of DevOps work. GitHub has GitHub Actions, for example, simple CI/CD framework. You can use that to automate some tasks like model training. Okay, build a GitHub action to do that, or indeed a redeployment. Use a GitHub action to kick off your MLflow package pipeline. That's a good way of starting to build that muscle memory of practically what do these things mean. I personally learned this field. Again, I'm a Microsoft person. That's just where my career has taken me. So Azure has Azure Machine Learning Studio, which is and there's also SageMaker on AWS, and GCP has Vertex AI. All of these platforms contain tools that you can use to help you, again, package up, containerize models and deploy it to Kubernetes or to a container instance. They do cost money, right? They're not necessarily free, but those things are there as well.
From a learning perspective, they may have resources as well, right? They'll have this short course. Yeah. Okay.
Yeah, and it probably isn't called MLOps, right? It might be, but it may just be parts of the work, like how to deploy a model, right? There's Microsoft Learn, for example, has various modules. One is deploying a model. It's not the full MLOps workflow, but it's the bits of it that you can go and learn and start to build up this bigger picture through that. Okay. But one of the current leaders in this is Chip Wynn. So she's at Stanford. She's got a course at Stanford on ML engineering. I think she was one of the first to have that. She's a good person to follow as well. She posts a lot of learning resources in this field. I followed her on LinkedIn. She's great. Can I post in the comments?
Yeah, can try, or maybe you can send it out to me. I'll probably add it.
But so Chip Wynn, so CHIP, and then her surname is NG.
Okay.
Nguyen. She's based out of California. She's great for this field as
There's
well.
a private chat option on the right side. You can use that. I'll just share it with everybody.
Yeah.
By the way, there's also what Lee has mentioned is, I'm pretty sure. Okay. Oh yeah. Oh, okay. Yes. I remember coming across her resources now and then, but it didn't strike me right away as took it. So one second, I'm sorry, I pasted it on the wrong place. So yeah, I'm adding it to the comment section. I'll also post it on LinkedIn towards the end of the session. So stay tuned. Cannot post it right away directly from this platform, but I'll do it. So stick around for a couple of minutes more till the end of the session. The next question that I want to pick up is something on these lines itself. Before that, I just wanted to mention there is I'm not sure, Lee, if you would have checked out about this MLOps Zoom camp. It's something that we partnered with very recently. It's so on D5 we also run absolutely end-to-end free courses, free boot camps, and MLOps Zoom camp is something which is dedicated to MLOps, and it's a boot camp which is 100% free. So somebody who wants to learn, they can also check that out. I'll also add a comment to that towards the end. There's one question that community member had asked, and it's kind of answered, but yeah, so this is I think for those who have the same question can check it out. They can just see he has given a pretty elaborate discussion in terms of comparing data science deployment analogous to CD of CI/CD, I believe. You want to add anything to it, Lee, or shall we
I just said that the extension of and why MLOps CD is a bit different, can be different to normal CD from an app dev perspective, is this retraining section, right? So I have this integration, retraining, then deployment, and sometimes the retraining could be classed as part of the CD process in an MLOps setting. Again, it depends how you're structuring it. I prefer to call it out separately because I feel it's separate enough. But a continuous retraining will normally be followed by a continuous deployment, right? That the kind of the two go hand in hand, whereas the integration is sort of a separate precursor. So that my only comment there is that figuring out where that retraining bit fits in, to the CI/CD piece for MLOps.
Okay. Also, there's this question that has been asked, which is on the lines of learning through implementation. I think, how does one gain expertise on the ops side of MLOps? The reason is I ask is one does get to be on the both the sides.
So this actually is interesting, right? Because as I kind of I think said in an earlier slide, this takes a village. MLOps is not there is, in my experience, the MLOps person doesn't really exist, just because the different skills are so different and it requires such depth. So personally, I actually, although I can architect out a full MLOps solution, I myself freely admit I can't do the ops side on my own. I personally partner with people on the ops side to implement the operations bits, right? The CI/CD. I can do it myself simply, but I'm not an expert DevOps person. I partner with DevOps people to do that. Really exist? And the monitoring as well, right? The people who do infrastructure, I partner with them on that as well. So, but what happens though is that by doing that, I learn myself from them. So that's kind of how I get the expertise. You find a way in, either as a data scientist with an interest in production, or as a software engineering person with DevOps experience, and then you partner with the other side, and then you use that to enhance your own understanding. You're open. You admit that you don't know it yourself, or that you can't do it yourself today, and partner with them, and they're the ones then who will really guide you in that. That would be my recommendation there. Rather than trying to learn all the things yourself, partner with those that already know the other side and use them as your key resource to learn.
Okay. Also, there was a paper that you presented in the beginning. Could you share a link for it? I'll also add that to the comment section.
Yeah, let me go and pull that out. Give me a second. Hidden technical debt. I actually called this yesterday. So, yeah, this paper is available. I'll post that in the... and it was done at New IPS, so it was done at a pretty prestigious conference. There you go. Post it in the chat if
Is
you
it
want
open for everybody to view?
Yeah. Yep.
Perfect.
Yep.
Awesome.
Yep. That is that paper is open to read, so that is the link to it, and it is open.
Okay, perfect. Also, one question that I had out of curiosity, and I'm very keen to ask that. So you mentioned this, it is certainly a known fact that a lack of understanding around MLOps tends to, uh, you know, break the success of a lot of ML data science projects out there. And you also went on to add that, a lot of Fortune 50 companies do not have, machine learning ops teams. So is that because they don't leverage data science to its fullest potential, or it's only about a matter of time, since this is something which has been coming up lately and there is a lack of awareness about the best practices around it?
Yeah, so there's a few. I've seen a few different things here, right? So one, some do have MLOps, right? Okay, so that's great. Those that don't tend to fall into two camps of people. Or two groups. Again, there's probably more. I haven't seen every company out there, right? I've only seen a few. But what I've seen is kind of two kind of concepts. One is that the data science is really more used as like advanced analysis. So they're fine with people on their own laptops doing an analysis once a month, once a quarter. And that's fine. That actually works for what they need. Of course, it means it can't necessarily be opened up to other users or be opened up to APIs or production grade stuff. That's okay. They don't necessarily need that. Could they do more if they were doing it? Well, of course they could. But they're happy enough where they are, right? And already seeing success, and they're becoming aware of this, and that will probably change how those teams function in the future. But they're still successful in that way. Just it doesn't necessarily need to be in production. The other kind are those that deploy to production and they have their data scientists maintain them themselves. I've heard and talked to some people where a team deploys a model and then a person might spend, and honestly, this was my first deployment back in 2017. This is how we did it, right? We deployed it and then I had a person spend a day a week maintaining it every week.
Okay.
Right? Now, and again, at the time that was fine, right? It was profitable. It was worth the while doing that. Of course, the person doing it wasn't skilled to do it. So although it was still monetarily worthwhile, data scientists, that kind of pirate persona, are good at innovation. So to me, my response to that is, but what if half that data scientist's time was spent innovating rather than maintaining, right? Playing to their real strengths and having somebody else who's more operational based do the MLOps piece. In that case, yes, it's still worthwhile them doing the maintenance, but there's also the opportunity cost of them not innovating because they're stuck in maintenance mode. So in both cases, I think there's a big case to be made for doing this to really help do things better. But by the same token as well, like if it's already working, don't fix it. Can be a mindset that you encounter as well. So
Okay.
That'll probably change as the field evolves.
Okay. Yeah, I think that's both of them are quite quite insightful, and understandable why it happens like that. I'll pick this question. I think it's kind of answered, but I mean, how long does it take generally to design automation pipeline within MLOps cycle?
I mean, it's very variable, and it depends also how much you're trying to automate. Because with that case study, they didn't want to automate everything from day one. They wanted to automate some parts, the parts that made sense to, but they didn't have all the answers up front, and they wanted to hold off on automating the retraining outside of a scheduled retraining as it kind of went on. So I mean, the good thing is, like a lot of DevOps work, once you've done it once, you can reuse a lot of the assets again and again and again, right? The basic tasks in retraining a model, doesn't matter what the model is. It could be, a simple scikit-learn. It could be some PyTorch monster. The tasks are the same, right, that occur in the automation steps. So we have templates that we can deploy to new clients very quickly, right? It takes a couple of days, if that, to update them for a new scenario. Now, because now we have them done. Yeah, it took us, a good few weeks to get them built the first time around.
Okay.
But the good thing is that a lot of the stuff here becomes reusable very quickly, right? It isn't like you've got to do it completely custom every single time. And that really does, as you kind of mature your practice of MLOps, cuts down the time enormously.
Okay. One of the questions that I want to pick next is it's something that we received over email. I kept a note of it beforehand. So this question that how is data engineering exactly related to MLOps? Is it kind of a prerequisite for learning MLOps?
No. So it's related, but it's not. Your data engineer persona and your MLOps persona actually are often quite different. But we do need data engineers to build the pipelines to feed our machine learning models in production, right? The connection point between the two is as part of the MLOps workflow, it can help to monitor your data inputs. Okay. Now, data engineers are already should already be monitoring data quality, right? Missing values, outliers in the data; those sorts of are already part of the engineering workflow. But the connection that is different for MLOps is we also need to do some monitoring of the input distributions of our data, right? Especially for key data points. Are they changing? If I've got a product table, right, and I'm adding a new product to it, that's a big change, right? For say a one-hot encoder, we need to detect that and account that in our MLOps workflow. But typically speaking, data and in that case study, the data engineers were feeding our feature store, right? Which yes is part of our deployed solution, but it kind of sits a little bit outside the MLOps part of the workflow. So you can combine them, and they are kind of they are linked. But generally speaking, I've seen different personas because also data engineering is its own unique skill set, right? Working in Airflow or AWS Glue or Data Factory or Synapse, those are distinct skill sets, often more related to data warehousing and transformation skills than software engineering skills. MLOps is kind of more comes from the software engineering and DevOps side of the house. So again, those personas are a bit different. But of course, you can do both. But I'd say that's not typical.
Okay.
Today, that might change in a few years' time, though, of course.
Yeah, certainly. I think this is something which is bound to evolve over the given coming years. Now that it has, now that people are discussing more about it. But yeah, thanks for answering that. The next question is around feature stores itself. It's something that Dhanasekaran has asked. He had asked a question earlier. You answered that. As a follow-up, he asked if there are any materials to read about feature stores. So anything that you can recommend to the ones who are,
So here's the thing with feature stores, is that because of kind of the point that it entered the space, and they've been discussed for a while. I'd say they start to actually be kind of released in about 2020, actual things that build feature stores. A lot of them are still kind of though used within proprietary platforms. There's a few that are open source like Feast, but most of them are proprietary. So just because, again, of my own experience, most of the ones that I'm familiar with are the Databricks feature stores. That tends to be where I use them myself. Not entirely, but there is if you're interested in like Databricks' view of feature stores, hit the link for that. I'll post their link. Now, but bear in mind that it's a proprietary platform. This is not an open source platform. But again, feature stores are an area where it's still very opinionated. No one, in my reading and my experience, again, this is my opinion, is that I haven't seen anybody say definitively, this is how you should use a feature store. Okay, different providers have different answers on it. If you ask Databricks, they'll say everywhere. Everyone needs a feature store for everything. And I'm like, I'm not sure that's true. But also, I think to bear in mind here is that feature stores, in many ways, are just rebrand databases or data lakes. Because what's a feature store? It is a database of features. Okay. Oh, but it has version control. Well, so does a database. If you've got a good dimensional model in your data warehouse, you already have version control over your data, right? You know when it was added. when it was deleted, right? All that stuff already exists in our technology stacks. So in many ways, feature stores as well it adds a bit of flavor and color to an MLOps workflow, and it's nice that we have a word for it because it means that these are our features exist in our feature store. But by the same token, they're also a thing that is still evolving, very much from point of view of their utility. Now, in the next couple of years, I imagine we'll have those answers definitively. But yeah, so that's a place just to start looking at feature stores. But just bear that in mind, they are kind of a database does all that if you build it correctly as well.
Right. One thing that is slightly contextual to your the use case that you had shared is basically what were the best and the worst response times in this case that you shared earlier.
Yeah. So that's actually a good question, which ties on a thing that I didn't mention, because again, I'm just trying to kind of keep it a bit lighter and simpler, is where in the world are you? Website's global. Okay, you can get it from anywhere in the world. Most websites, though, are probably only being run in one or two countries, right? So in this case, this website was being run in the US. So if you were from Southeast Asia, outside of the world, your request had to get from Southeast Asia to the US, inference, come back, and stuff. And even at the speed of light or communications, that takes a few fractions of a second to go from Southeast Asia to the US. So the worst response times were actually just over a second, of which more than half of that was getting from Southeast Asia to the United States, and kind of that part of the world. In terms of fastest times, if you were close to the website in the US, then or its hosting place, then it was under a second. Now, there's some variance there as well, and if we had a lot of traffic coming in, things might have suffered a little bit. We never got to the point. It will eventually, where we had the traffic that would have caused, say, timeouts to occur because there was enough, replicates to do it. But the variance just on travel time was over half a second based on where you were in the world. There are ways around that, though. Like you could have, local. You could deploy your model across the world, right? You could deploy your model, say, to the US, to India, to Europe, to Africa, somewhere in Africa. I think there's a data center somewhere in Southern Africa, Microsoft or AWS, and then then you can have it choose the nearest data center, the nearest model location to where you live, and that can pull down latency times. But as you can imagine, if I've got to deploy models now to 5 parts of the world, that adds a bit more complexity into my system, which is doable, dealable, but we didn't do, again, for the initial use case for this particular scenario.
Okay. There are a couple of more questions that we'll be picking. So this is the one. Okay, this is it's showing as LinkedIn user probably because, so this question is, does the API store features in real time for the case study?
It's near real time. So there was a small latency, which actually was on the website. Website themselves didn't output the data in real time. There was some I kind of what it was. There was a small latency in place between them, the actual clicks happening, and then the website bringing them, publishing them for us to use. So it wasn't real time, but it was close to real time. It was, I can't remember what it was, but it was, I think a few tens of seconds latency delay between the clicks occurring and the data appearing.
Okay. This is question asked by, so this was asked by Chinmoy. The next question is asked by Sachin. It says, when model takes multiple hours or days to learn, how these trainings are planned and monitored?
Okay. That is a very complicated question. can be complicated. Many things to think about. So let's take a couple. I worked for in the past. So I worked for a startup, and our model. This is back in 2017, 2018, 2019, 3 years ago, 3.5 years ago. Really powerful model, doing some amazing computer vision work. It took about 6 days to train. That it's probably changed by now, but back then it was in our dev phase, when we were in our pilot phase, about 6 days to train the model, because it was 2 models back to back that had to be kind of trained in sequence to do the full and the second model, the first model's outputs were an input into the second model, so it was 6 days to train. In that case, we had to be careful with that, but also we then didn't want to retrain on a schedule. We wanted to very, very much do that. I'm going to retrain when I need to. Okay, retrain when the conditions, when my monitoring solution tells me I've got to retrain. In our case, it was more because we had new data points added. It wasn't because of degradation of quality. It was more that we kept adding more image classes to our computer vision classifier. Kind of cool. But again, we couldn't retrain that. 6 days to train a model on GPUs. That's also expensive from a money perspective. So we only retrained when we had to, which was totally worth it. I mean, the model was phenomenal. And the company is stellar. They're really going places right now. But in that case, there was planning involved, and there was definitely doing it at the right time. If it is honestly, hours to learn isn't a problem in the modern world for the most part. With hours to learn, we can just plan it on whatever kind of thing that we do. But monitoring training is going to be important, and a lot of them tracking tools, especially say you're doing TensorFlow and you're doing epochs, or similar, PyTorch, and doing that kind of regular epochs of training. A lot of them offer ways in which you can hook TensorBoard into them or equivalent tools to then output an epoch. You can output the data to there and kind of keep your tracking going as the model's going. Honestly, I haven't done a lot of that myself, kind of hooking that sort of stuff into these personally. But I know it's possible with quite a few of these tools, because they know that if you train for 6 days or a week, you don't want to just have to leave it all till the end in case something goes wrong. You've got to restart from your checkpoints.
Okay. Thanks for answering that. This is last question that I'm picking for the day. Does MLflow support deployment to Android?
I'm not quite sure, but let me tell you what I do know, right? So MLflow is available in Python and a few other languages as well. I think it's in C# too. But let's take Python, right? So Python, MLflow, we run our Python code. It's just a Python library at that point in time. I can then use MLflow to deploy a container, Docker container. So I haven't ever done this before to Android, I'll be honest, and I don't know how this would work because I'm not an Android expert. Well, I'll be honest, I actually know very little about Android at all. But the output of that process is a Docker container that you can then register in Docker using Docker Hub or something else. So assume that your Android app can run Docker. That container that's built, it should be able to pull that container down and deploy it to, an Android environment if you can run Docker in Android. And that's what I don't know. I've never done that. I'm not an Android person, but that would be the prerequisite. Does Android support Docker? It probably does. If it does, then yes, you can build a pipeline from MLflow to push the container up or the image up and then pull it down into Android. I don't know how to do it myself, but that should be possible, I would imagine.
Okay. Well, so I think that was the last question for the day. There have been a lot of people who have been putting out their appreciation for the wonderful presentation and the pretty insightful answers that you gave. This certainly came from a lot of experience, evidently. So thanks a ton for being with us today. There's a couple of things that I want to mention before we wrap this call. So a lot of people were asking for resources that Lee had mentioned during this session. So we have been adding them in the comment section. So please feel free to check them out. this is the courses bit that we shared. I was looking to share this. Yeah. So if you want to share this session, amplify its impact. So please feel free to do that. The recording will be there on YouTube and LinkedIn. While doing that, you can feel free to tag DeFi and Tallan. I'm not sure if I'm pronouncing it correct. It's Tallan, maybe.
So it's actually so the original founders a long time ago were Irish. So it's actually Tallan, because Tallan is Gaelic for talent.
Oh, okay, that's insightful. Nice. Okay, great. So, okay. So yeah. So for those who want to, I'm not sure if you're on Twitter. I couldn't find it myself. Just trying to do that.
I'm
But
not on
yeah,
Twitter, I'm afraid.
okay.
I choose LinkedIn as my platform of choice. So
Yeah, so folks who want to follow Lee on LinkedIn should feel free to do that. We have been tagging him on LinkedIn for, I mean, in all the posts that we've made lately. So just go on LinkedIn, check them out, check out his profile. Yeah, that's Lee's profile. It's tagged almost everywhere, so you should go out and follow him, because certainly you might get something to learn on a regular basis from his LinkedIn too. So thanks, everyone. There's also one last note of love. I'm sorry, I'll have to open LinkedIn to check who this LinkedIn user is. But thank you so much for the kind gesture, and thanks eternally for being with us today. I think it was really insightful for the community and for me as well. Learned a lot of things, and it was a pleasure hosting you today.
well, pleasure to be here. Thanks everyone for coming. And as I say, you know, this is a growing field, and thank you for taking the interest in kind of adding to its long-term success.
Yeah, certainly. Thank you. Bye, everyone. We'll be meeting you soon in the next Saturday. Check out defi.tech/live sessions for more sessions on these lines.